everyone, welcome back to another video. In this video I'll be going through negative indices. Negative indices. So in my previous video, which was actually quite a while ago, so apologies for not uploading. But in my previous video I talked about 4 index laws, which are right here. You should probably note them down right now. We talked about what indices are. We delved a little bit into prime factorization. Well, in this video, we'll be going through all stuff negative indices. So we're going through applications, how to convert them into a positive indice, and bagera. So first of all, we have these two rules. A to the power negative m equals 1 over a to the power m, and a to the power m equals 1 over a to the power negative m. So we always need to keep these in mind. So let's try to put these in practice. So let's say we have x to the power negative 2. Well, this fits this law. So x is a here, so this would be a, and then negative 2 would be negative m. So that would basically equal 1 over, well, if a is x, that means x would be here, and if negative 2 is negative m, that means 2 would be here. So that's what our answer would equal. So essentially, for this law, a to the power negative m is basically the reciprocal of this fraction right here. Okay, let's try another example. So let's say we have something like 3a to the power of 2, negative 2, sorry, times b to the power of 4. Well, if we break this down, this may look a little daunting at first, but if we break it down, it essentially equals 3 over 1 times, well, a to the power negative 2, that would obviously equal a divided by 1 divided by a to the power 2, and then that's also multiplied by b to the power 4 over 1. And now if we multiply all of that together, it would be 3 times b to the power 4 over a squared. So you see how I broke it down really clearly. So the 3 is here, a is here, b is here, because essentially they're all terms being multiplied together. Okay, so let's try something else. So let's try 2x to the power negative 4 y to the power 3. So if we break it down, essentially equals 2 divided by 1 times, well, x to the power negative 4, that equals 1 over x to the power 4. Multiply that with y to the power 3 over 1. So now if we expand that and see what happens, that would be 2 times y to the power 3 over x to the power 4. So it's as simple as that. Okay. Now we'll be using this, the second law, which is this one. So we'll be trying to use 1 over a to the power negative m to get a to the power m. I should probably switch these two around just to make it easier. So 1, oh, pardon me. So 1 over a to the power negative m equals a over m, a to the power m. So let's try and do an example. I'll just rub all this out. So let's try and do an example. So let's say we have 1 over c to the power negative 2. Well, once again, we can substitute everything. We have the 1 in place. A to the power negative m, well, a would be c, and then negative 2 would be the m. So now we can make it, well, since a is c, it would be like this, and then since m is negative 2, it would be like this. Okay, Let's try something else. Let's try something a little bit more harder. So x to the power negative 3, let's say this one, x to the power negative 3 over y to the power negative 5. Now, this may look like we cannot use the index law. However, this is essentially, we have to break it down. It is essentially x to the power negative 3 multiplied by 1 over y to the power negative 5. And now we can use this law here to change this, because this essentially equals x to the power negative 3 times, well, this is essentially y to the power 5. So we converted it. So this essentially is now y to the power 5 over 1. And now if we now multiply everything, it would equal, actually we need to do one last thing. This x to the power negative 3, we can convert it into a fraction, so x equals a and negative 3 equals m, so it would be 1 over x to the power 3 times y to the power 5 over 1. Now we can break it down, and our answer is y to the power 5 over x to the power 3. So that's how we got our answer. Now something else I want to go into, now that we've got over negative indices. In my previous video we went over prime factorization, and let's just do a little bit more on that. So for those who don't remember, prime factorization is essentially breaking a number down until it can only be multiplied by prime factors. So in my previous example, I used 108 here, so we kept on dividing it. So we had 2 and 54 in this instance. Then we can divide 54 and 2. Then we can divide 27. Then we can divide 9. So we essentially keep on finding numbers until it can no longer be broken down, and then we use those numbers. So essentially we ended up with 2 times 2 times 3 times 3 times 3. That's essentially 2 squared times 3 cubed. So let's try another example. Let's say we go something along with I don't know, 150. Why not? Let's go with 150. So if we divide it by well, the first things I can think of is it can be divided by 3 and 50. So we can see that 3 cannot be divided by anything anymore. So we try 50. 50 can be divided by 2 and 25. And 25 can be divided by 5 and can be multiplied by 5 and 5. So now we have all of our prime numbers. So it's 3 times 2 times 5 times 5. So that would essentially be 5 squared times 2 times 3. And we can even check if this works. So 5 squared equals 25. 25 times 2, that equals 50. 50 times 3, that equals 150. So you can see that this works. Let's try something else. So let's say we do 208. So I'll just rub all this off. So let's just do 208. So 208, well, it can be divided by 2 and 104. So 2 cannot be divided by anything to make it 2. So what can 104 be divided by? Well, that can be divided by 2 and, well, 104 divided by 2, that equals 52. Now what can 52 be divided by? Well, if we have our multiplication, if we know our multiplication, we know that it can be 13 times 4. So in this case, multiplication is very evident. Now 13 is a prime number, so we can still keep it. So we have to divide 4 with 2 numbers, and that would be 2 and 2. So now we have all of our prime numbers. 2 times 2 times 13 times 2 times 2. So there's 4 2's, so it would be 2 to the power of 4. And there's only one 13, so it would be multiplied by 13. So that's how we use prime factorization. So so that's enough in this video. So in this video I went through negative indices, what they are, 2 rules to jot down, some applications, some examples, and we also did a little bit more on prime factorization. If you've been enjoying my videos so far, be sure to like, subscribe, and comment what I should do next. Please share this video, as it really does motivate me to keep on helping through this platform, and until next time.